Hello everyone. We are going to see an important topic in ray optics, that is spherical aberrations in lenses. First of all, see the mean of word aberrations. Aberrations normally refer to the deviation which is not uh, clear, is known as a aberrations. Aberrations in lenses is related with the image of a lens. If the image of the lens is not obtained clearly, if it is enlarged, then it is known as aberrations. This is enlarged in size, or maybe a point object if its image is enlarged, or any image formed by the lens is enlarged, not clearly obtained, is known as aberrations. We are going to watch spherical aberration in the lens. So to see the spherical aberrations in the lens, let us see this diagram of a convex lens. Let us consider a convex lens. In this convex lens, consider a principal axis. In this convex lens, consider a parallel ray of light. Falling on convex lens. The parallel ray of light near to the convex lens, this both, which is represented by a single arrow, is called paraxial rays, and the rays which is represented by double arrow away from the lens is called marginal rays. Now see what happened with this paraxial rays and marginal rays when parallel beam of light is allowed to fall on a convex lens. Then it is obtained that the general rule is that all the rays will focus at a single point, but here the parallel ray of light which is near to the principal axis, called paraxial rays, meeting at a point, at one point, focusing at one point. This point is known as focus for the paraxial rays. Wherever the marginal rays meets much earlier to the some earlier, not much, some earlier before the point FP. This is known as focal point for marginal rays. There is a large gap between both. The intermediate rays between paraxial rays and marginal rays settled between the point FM and FP. FM and FP. So image of the object formed between FM to FP. We can say that the parallel rays rays not focused at one point. In place of focused at a single point, it's settle up to range from FM to FP. That is why the defect in image is obtained. This is called aberrations in the image of a lens. It is due to the reason, see the reason behind the aberrations. It is due to the spherical shape of lens. The main reason behind this defect in the image obtained is due to spherical shape of the lenses. That is why this aberrations is called spherical aberrations in lenses. Why this spherical shape is responsible for the defect in the lens, the images which is enlarged, because the different part of the lens is different thickness. That is why it has a different focal length or focal point. That is why it acquire a range. Now let us see in spherical aberrations when we take a point object. When we take a convex lens, let it is a principal axis. The convex lens has a spherical shape. Different part have a different thickness, different radii of curvature and thickness. That is why its focal point is a different. Let us consider a point object is here. When you take a point object, for this point object, when we take the paraxial rays near to the lenses, it focused, let at this point. This point is known as IP, image for paraxial rays. Let it is represented by a single arrow, whereas the rays which is away from the principal axis called marginal rays, let its image is obtained at this point. This is before the image formed by the paraxial rays. Let this point is marginal rays IM. It shows that, let this is a line of IM and it is IP. This is distance between. So image is enlarged between IM to IP. This IM to IP is known as one term, that is axial aberration or longitudinal aberrations. So see very carefully. So point object is a point object O. Its image is formed from here to very large. The intermediate rays settle between IM to IP. When we place a perpendicular plane in between that, then image of point object is formed in the shape of circular disc. And when we move the screen which is parallel to the principal axis from IM to IP, the size of the image which is formed in shape of a disc changes. The place where it has a minimum shape, when it has a minimum shape, in that condition, we may say that the paraxial rays and marginal rays crosses each other. So it means here this side, from here this side marginal rays, this side paraxial rays, and the radius of the disc is called, this radius of called circle of least confusion. And the radius of circle is called lateral aberrations. In this diagram, the lateral aberration is represented by the green light. This is lateral dispersion, axial lateral aberrations, axial aberrations. So this is whole about the topic. See carefully. Spherical aberrations in the lenses. We will see how we can remove the phenomena of spherical aberration. We will show in the next video. This is for the topic only. Thank you and have a nice day. 1 minute को